Hello and welcome to this video demonstration of gas detection mapping using HazMap3D from Micropack Engineering. In this video I'm going to continue on with the detection analysis from my previous video on flame detection mapping and demonstrate the gas detection analysis made possible within HazMap3D. The standard method applied in this example is volumetric coverage. This is widely regarded as the most robust method of designing these systems, as it's the only method with relevant empirical evidence to justify its application. However, other methodologies are available within HazMap3D. This method is often incorrectly simplified or misinterpreted to simply putting a detector every 5 meters, but this is wholly inaccurate of the appropriate way to design such a system. There are a number of targets which must be set in the lead up to carrying out the gas detection mapping. This includes the analysis of potential explosion overpressures in a given area, which will in turn provide you enough information to target a specific gas cloud. Tools such as CFD can be useful in the generation of a target gas cloud, for example using explosion modelling. However, Micropack would recommend avoiding the use of dispersion data as the sole method of placing devices, particularly in unpredictable environments. Of greater concern is the potential of placing devices based on some scenario-based analysis or consequence modelling, which generally looks at less than 1% of the credible scenarios in a given area. At the end of the day, it's important to remember that any material in the gaseous state represents the ultimate expression of disorder, and by definition will fill all available space in which there is a random distribution of molecules or atoms. As such, where modelling of any form is to be used in determining the layout of gas detectors, dependent on the application of course, it's reasonable to suggest CFD explosion modelling should be the only tool used as an input to the gas detection mapping process, although this is not always the case. The issue unfortunately arises that CFD is quite an expensive method of design and is rarely carried out, but that discussion could easily fill a separate video. At this point we'll move on to review a typical gas detection assessment, but remember that with HazMap3D, the user has a direct line to the Micropack consultancy team who can assist with the matters previously discussed or any other concerns regarding the application of gas detection. So first of all, we have to assign an adequate grade to the area. These grades are assigned differently from the previously assigned flame detection grades and look to detect clouds of gas rather than static flame locations. So let's just hide our flame assessment for the moment. And we're going to add our gas detection volume that we'd like to detect. So previously we looked at an elevation of 4 meters, so we're just going to keep that the same in this case. So we're going to add our volume simply by clicking the 4 points. Could be more, and you can make more complex shapes, but for the purpose of this example, we're just going to double click on the final point to create our gas volume that we would like to assess within. Now within this volume, the user can obviously specify what target gas cloud we would like to look for. At this point, however, we're going to continue on with adding some gas detectors within the scene. So we're just going to rename the gas grade, gas volume, for ease of reference. Okay, so we'll hide that for now, and we're now going to add our gas detectors. So we'll add a couple of open paths first of all. So we're going to add open path gas detector, and as with flame detection, you simply double click on any solid surface within the model for the transmitter and then for the receiver. Now as this is a fairly open area, we're going to make the assumption at this point that the analysis before this point has justified that a 10 meter gas cloud will provide the explosion overpressure that we want to mitigate. So the detection radius in this case is 5 meters, and we can see that applied here. It's important to note though that this is not 10 meter spacing. We're not simply being prescriptive. We would always encourage a performance-based design to try and justify what target gas cloud is being analysed. So we'll hide that gas detector for now, and we're just going to add in a second open path detector. Okay, and obviously the software remembers that we're looking for the 10 meter gas cloud. Okay, now this is a 2-out-of-n system in this case, so we're going to have to add a third detector for redundancy. The reason I'm going to add the third detector in the example though is to show you one of the features of HazMap3D, that we want to put a gas detector into this area here, but there is no mounting location within this area. So what we're going to do is we're simply going to add the point gas detector on the ground and elevate that up to an appropriate elevation. Now that's fairly simple in itself, but what comes standard in HazMap3D is when you automatically generate your report, the report for this specific detector, along with the tag information, the coordinates, the manufacturer, the model of the device, you'll also have a note automatically generated which tells the project team, which tells the installation team, that this particular device will require a mounting post and a mounting bracket, and essentially all the practical things that you need to add that detector in that location, which are not automatically obvious when reviewing the coverage assessment. And this is where HazMap3D really stands out as the engineer's choice for fire and gas mapping. At Micropack, we understand what's required to actually install these systems, what's required to design these systems, procure these systems, and all of that information is provided to the engineers in HazMap3D. So we're now in a position where we can run the assessment. So in order to do this, I'm just going to include the other gas detectors, obviously turn them off from the view to keep it nice and tidy. And we're going into assess. Similar with flame detection. Obviously there's no existing gas detectors here, so this is a proposed assessment. And the shoebox volume is exactly the same as before. Number of Z steps and the representative Z is exactly the same. So we can now assess the volume. What we have represented here, the green areas represent the centre point of the target gas cloud which intersects with the specified detectors. And what orange represents is the centre point of the target gas cloud, in this case 10 metres, which only intersects with one device. So essentially we have our control action and alarm action specified with our percentage in the top left hand corner here, which is very useful for the engineers to review coverage achieved. It's a common misconception that the gas detectors provide a coverage like a flame detector. Obviously that is not the case. These are passive devices and we're simply looking for the points that the centre point of our target gas cloud will intersect and provide an alarm from these units. Obviously this is not the only methodology available in HazMap3D, but it's certainly the most common in our opinion, from our experience. If you have any questions regarding the software, either technical or commercial, or if you'd like a 14-day free trial, please don't hesitate to get in touch with myself or any of my colleagues at Micropack Engineering, details of which are provided in the video description. Again, I would encourage anyone with an interest in fire and gas mapping or any other fire and gas related topics to register at the Micropack forums or on the Micropack Fire and Gas discussion board on LinkedIn, details of which are also provided in the video description. Thank you very much for watching.